Interesting question, this. It's difficult to work out what to do, isn't it? How do we expand that there? The n's not a number. So it all revolves around putting this into polar form. So let's just try that. So it's minus root 3 plus 1 and minus root 3 minus 1. So it's going to be 5 pi and 6 and minus 5 pi and 6. And then clearly they're too long. So it's going to be 2 cis 5 pi on 6. Bit messy. And 2 cis minus 5 pi on 6 to the n. We're going to use de Moivre here. So 2 to the n cis 5 pi n on 6 plus 2 to the n cis minus 5 pi n on 6. Let us factor out that 2 to the n because we want to apply the null factor law. I'm just going to do that in a different colour. So I'm going to factor out the 2 to the n. And clearly that 2 to the n can't be 0. So we're only left with cis 5 pi n on 6 plus so that's what the question boils down to, is how am I going to get that equal to 0? Let's expand it, make it bigger. Cos 5 pi n the next one and again we get to a bit of a stumbling block, and hopefully we've got an understanding of trig symmetry. So let's look at cos theta and cos minus theta. So what we're looking at here is there's a 5 pi and a minus 5 pi, a 5 pi and a minus 5 pi. So we want to sort of simplify that trigonometry. So if there's theta and there's minus theta, cos minus theta is going to be the same as cos theta. If there's theta and there's minus theta, then sine minus theta is going to be the minus of sine theta. We do a bit of that in methods. So hopefully what we're going to do is we're going to simplify this thing here, and we're going to go, this all stays the same. Because we worked out before that cos minus 5 pi on 6 is the same as cos 5 pi on 6. So we can just do that. So now they are like terms, and we'll go to 2 cos. And we also worked out that, get rid of those circles, we also worked that this sine goes to minus I sine. And they're like terms, and they go to 0 because I'm subtracting one from the other. So I'm left with, my gosh. And get rid of the 2. We're home and hose from there. 5 pi n on 6. Because of what is 0, we're going to go pi on 2. Why isn't that working? 2 Let's get the n by itself. So we're going to multiply by 6 and divide by pi. It's going to be 6 on 10. 3 on 5, 9 on 5. Whatever it is, it keeps on going. Now, I think this is a leftover from the last syllabus where we had sequences and series, because it said for all of n. So the answer there is, I don't think that could be in this external exam, but if you can think that this n is going to be something on 5, 3, 9, 15, 21, etc., etc. So we're adding 6 each time. So that's a arithmetic sequence and series straight from methods, and that's how we get that answer in there. I don't think that we're too worried about that, but I really like the playing that we need to do in that proof. Hope you enjoyed it.